Hey guys, we're going to be on lesson 5-4 today, and we're going to be talking about something I think we referred back to when we were doing decimals and division. Today we're going to talk specifically about terminating, which is when you have no remainder, and repeating decimals. And we talked about that one too with repeating bars. Repeating decimals. And today's date is the 13th. Monday the 13th, 1/13/2020. Oops, 2000. Let's try that again, 2020. So we start off with a vocab word that showed up on our test because we talked about this in chapter 2. Rational number. So a rational number, I'm going to highlight a special word here, ratio. Okay, so a rational number is any number that can be written as a ratio. So there's that special word, ratio. And then we talked about in chapter 4 that a ratio is a fancy word for fraction or fraction. So rational numbers, any number that can be written as a ratio, so a value being divided by a value. So decimals fall in one of two categories. You can either have terminate, or let's say decimals, those that terminate, Patches is saying hi, and terminate means ends, so those that terminate end, so there's no remainder, or, oops, wrong color, or those that repeat. I'm going to say those that terminate and or repeat. So let's do it that way. So that means continues in a pattern, the same number over and over and over again. So we can repeat with just one number. We can repeat with two numbers. We can have a terminated number and then it repeats after that. We can have a 6-digit repeating number. That's the worst case scenario when you divide by 7. So we're going to remind ourselves how we convert fractions to decimals. So if you didn't pick it up then, now you get to. We're going to take an example of like 1/4, and then that becomes 4 dividing into 1, or the denominator is your divisor, and your numerator is your dividend. Okay? So again, we want to mention that the terminating decimals have no remainders. So it ends. You don't need it. Now, sometimes you have to bring down a 0 and continue dividing in order for that to happen. So let's go ahead and we're going to do some practice problems on this. So directions are going to say write each as a decimal. So again, chapter 3, here we are. And we have 4/5, so we're going to divide 4 by 5. Now, since 5 can't go into 4, we put up a 0, but that's when we get to add a decimal point, bring it straight up, and then we can start annexing the zeros. So 5 goes into 40 exactly 8 times, so that's called a terminating decimal. So that answer is 8/10. Okay, let's try another one. Now, the reason why we're doing this again is because what if we have a fraction that's negative? Ooh, what is that going to do? Okay, well, if you think about zombie elves, the clue that we did together, I think it was number 2, in multiplication or division, if the signs are the same, so 2 negatives or 2 positives, you're going to get a positive answer. But if the signs are different with your 2 numbers, then your answer is going to be negative, okay? So what I'm going to do is I'm not going to show the negative here, 8 divided by 25. I'm going to put it all the way into the answer, so then I won't forget about it. So, bam, he goes there because there's 1 negative. So again, 25 can't go into, oops, I'm going to put that into black. Oops, go back. Oops, go the other way. There we go. I'm going to go to black. And we have 25 goes into 8 0 times. That's when we put in a decimal point, bring it straight up into our quotient, and annex a 0 and continue to divide. Well, 25 goes into 83 times, which is 75. We have a difference of 5. So we get to annex another 0, just one at a time. And 25 goes into 50 exactly twice. So this is, again, a terminating decimal, and the answer is going to be negative 32 hundredths. Excuse me. So as a little reminder over here, a negative fraction will equal a negative decimal. Now, when I took my notes, this was the end of the first page, because the second page, we're going to talk about repeating, and that gets to be a little long. So I'm going to switch over to my second page. So I'll get my title in here. Lesson 5-4, Terminating, which we already did. And repeating decimals, and that's what we're going to do now. So we're still on the 13th, 2020. So let's give you a definition. Let's do a repeating decimal. Can you hear my kitty cat? She's kind of purring. She's in this, like, trying to knead me. Like, that's how she gets all cozy. So, a repeating decimal is a decimal with digit, and then remember we can use those parentheses, S, so that means you can have one digit or more than one digit that repeat. And I can put here, repeat or repeat. So 1 digit repeats, 2 digits repeat. Get it? Okay. Now, how do we signify whether we have a repeating decimal or not? We use something called bar notation. So I can't remember, I think some of you guys said you did this in 5th grade, which, that's cool. So bar notation signifies, that looks funny. Yeah, it does, because there's no A. Let's try that again, shall we? Like, that didn't look right to me. That looks better. Signifies that a digit or a set of digits repeat. I should say set of digits in a decimal. Yeah, you can't do it with a fraction or a whole number. Okay. So here's some things we got to remember when we use bar notation. 1, we're going to write the digit. Wait, let me put the word the. Write the digit or digits. So when I say digits, it can't be the same one over and over again. It's got to be 2 or more that are different, that repeat. only one time. Okay, so you're only going to write what repeats once, right? Then you're going to draw a bar. So it kind of looks like this, our bar notation, whoosh, over the digits that repeat. Draw a bar over the digit or digits, so that's what the S means, that repeat. Okay, we've got 2 examples, and then we'll be done for today. So the directions say, write each fraction as a decimal, same as before. So example 3, I'm going to give you a nice one. Well, I'm going to give you kind of an okay one, and then I'm going to give you the nastiest one possible. So we have 5 divided by 12. So 5 divided by 12. So 12 can't go into 5, so we put a 0, and that's when we're allowed to put in a decimal point into the dividend, bring it straight into the quotient, and then annex a 0 and start dividing. Well, 12 goes into 40, let's see, 3 times, which is, nope, sorry, it's into 50. That would be 4 times, which is going to be 48. So when I subtract, I get a difference of 2. That allows me to bring in another 0, annex it, bring it down, and 12 goes into 20 only one time, and there's a difference of 8. So I need to annex another 0 and bring it down, and 12 can go into 80. Let's see, 7 would be 84, 6 would be 72, so we can only go to 6, which would be 72. When we subtract, we get a difference of 80. So then we annex a 0, bring it down, and all of a sudden you're going, wait a second, isn't that what I just did? And the answer is, yeah. 12 goes into 80 6 times, which is 72. So you notice what's going to happen from here on out. You're just going to get a difference of 8. So this is where we stop. And we're going to write each of the digits once. And then notice that it's only the 6s that repeat. So we're going to just put a bar over the 6, not over the 4, not over the 1, never over the 0 in front of a decimal point, and never over the decimal point. Okay, here comes the worst one. And by the worst one, this is the longest division you will ever have to do. Okay? Because, well, that's not necessarily true, but this is the longest repeating answer you'll ever get. So we're going to go ahead and rewrite it. Now remember I said I'm not going to put the decimal in the dividend. I'm just going to put it up in the quotient so that I don't forget about it. So it goes there. All right, so since 7 goes into 5 0 times, I'm going to go ahead and then put in a decimal point, bring it up into the quotient, annex a 0, and start dividing. 7 goes into 57 times, which is 49, and when I subtract, I get 1 left over. So I got to annex another 0 and bring it down. 7 goes into 10 exactly 1 time, and there's a difference of 3. I still have a remainder, so I need to keep going, so annex another 0, bring it down. 7 goes into 30, let's see, 4 times, which is 28, and a difference of 2. So I'm going to have to extend my, what do they call that? I forget what it's called. Vinculum? No, I think that's something else. No, that might be it. I'll have to check that and let you guys know. It's a funny word. So another annex 0, bring it straight down. 7 goes into 20 twice. 3 would give me 21, so that's too much. So it goes in twice, difference of 14, and we get a difference of 6. Got to annex a 0. 7 goes into 68 times, which is 56. And then we get a difference of 4. So if we annex a 0, and 7 goes into 40, let's see, 5 times, which is 35. Get a difference of 5. Annex a 0. Oh my word. See, I told you this was evil. and 7 goes into 57 times. Gosh, I have to make this longer. Wait a second, 7 times. Okay, that's weird. Did you notice what happens? I have a 50, which means it'll go in 49, which means I'll have a difference of 1, which means I'll have a 10. It's just going to be the same stuff over and over again. So what I'm going to do is I'm going to write down the answer. And there's a negative in front. There's a 7, a 1, a 4, followed by a 2, an 8, a 5. And then it starts the repeating. So all of these are repeaters. So the 7, the 1, the 4, the 2, the 8, the 5. So this is why this one's evil. So dividing by 7. Unless the number you're dividing into is a multiple of 7, always results in, okay, I know always doesn't seem right if I just said, well, in the case of this, that's not true, results in a 6-digit repeating decimal. So be prepared when you see that that's what's going to happen. Okay? All right, that's it. Have a good one, guys. See you tomorrow. Bye.